Hi viewers, good evening everyone. I am Dr. Gopi Krishnan, working as Associate Professor in the Department of Aerospace Engineering. This is going to be a lecture series on the course Aircraft Manufacturing Technology. I'm going to take the topic uh, in the subject. We are going to see the aircraft composites chapter number 1 for the first part of the video. And what are the aircraft, what is called as an aircraft composite? The definition is very simple, that a composite material is going to be a component that has two or more constituents which are mixed together or combined together in the aircraft applications, are called as the aircraft composites. For example, if the composite material is composed of two different components, they are mixed together in the macroscopic scale. That is, for example, concrete is going to be one of the best example for the composite material, in which we use the cement material, we use the rods, and we use the bricks for making the concrete. So we are combining all these components. Each component has a definite role, and each component is taken in the similar form, and they are mixed together in the sense they are combined together without losing its macroscopic property. That is, the shape, geometry, size of the each component is not at all changed, but they are combining together to give some kind of superior properties. For example, for the reinforcement, we are adding the rod for getting a structure, we are adding the bricks, and for the bonding between the bricks and the rods, we are going for the attachment of cement to the system. So these two or more constituents, they are mixed together or combined together in order to get the superior properties. And this is taken for a particular application, which is called as the which is nothing but the aircraft application. So the composite materials that are used for the aircraft materials are called as the aircraft composite material. And why these components are mixed together, combined together? Because of some useful applications or some useful outputs from the materials. That is, we require the lightweight for the aircraft, because when you are reducing the weight of the aircraft, we can improve the reduce the consumption of the fuel, and we can improve the operability of the aircraft materials. We can increase the strength, because the weight is reduced, but we are not compromising with the strength. So strength to weight ratio is very larger as compared to the other applications. And an aircraft is a component or a system that is susceptible for uh, many environmental factors, such as corrosion, such as air resistance, and these kind of materials are providing the resistance to the environmental factors. So these composite materials are very, very important. And what are the key characteristics of the composite materials? We have a number of key characteristics, and a few important key characteristics of the aircraft composites are: it becomes a very lightweight and a high strength to weight ratio, corrosion resistance, fatigue resistance, design flexibility are the important key characteristics of the aircraft composites. And what are the commonly used composite materials? We have a number of components which are clubbed together to be called as FRP, CMC, and MMC. FRP are called as the fiber reinforced polymer matrix composite, which can be called as PMC, but since the fibers are used in the aircraft composite applications, we call it as FRP instead of FRPMC. And the second category is the ceramic matrix composites, and the third category is the metal matrix composite. So you have to add two different materials. One is matrix, another one is a reinforcement. And matrix is used for getting the structure, that is used in the larger proportion, and reinforcement is attached to the system for giving the reinforcing capability or the property. uh, the components subsequently, they can be called as the composite materials. So when the fibers are reinforced in the polymer matrix, that is, fiber is going to give the strength and the polymer is going to be the larger component. So this kind of materials can be called as the fiber reinforced polymer matrix composite. It has three classifications. When you are adding the carbon, it is called the CFRP, and when you are adding the glass, it is called the glass FRP. And when the aramid, uh, that is a kind of a polymer and which has a specific properties, those are called aramid components. When the aramid components are attached together in the form of fiber, it can be called as ceramic fiber reinforced polymer matrix composite. And the second category, it is called as the ceramic matrix composites, which are used in the jet engines and exhaust components that can handle a high temperature. It gives a high resistance to the high temperature applications. Third category is called as a metal matrix composite, which can be shortly called as MMC. That is, mainly aluminum and titanium components are attached together or taken as the matrix material in the MMC, with the ceramic or the fibers for the enhancer properties. The applications in aircraft: fuselage and the wings are the very important components which are made by the composite materials in the Boeing 787 and Airbus A350, where over 50% of the structure is composite based. For the tail section, which can be called as empennage, the critical structural components like the rudder and the stabilizer, we are using the composite materials. For the interior of the aircraft applications such as cabin panels, overhead bins, and flooring, use lightweight composite for the comfort and the efficiency. For the engine components, fan blades and the casings in the jet engines utilize the composites for the performance and the durability. For the landing gear and the control surfaces, lightweight and durable materials for the maneuverability are made up of the composite materials. And these are the different components that are combined together uh, to to make an aircraft, and each component is responsible for a certain application. For example, if you are taking the rudder, this is going to be a very important component which can be used for altering the yaw position. That is, yaw is nothing but uh, the rolling stability of the aircraft while flying. And when you are going for the change of the rolling, you have to go for the aileron, which is attached here. And this is going to be the structure called the wing, which generates the lift here. And the horizontal stabilizer and vertical stabilizer are there. Horizontal stabilizer and vertical stabilizer, they are used for controlling the pitch and the yaw. And the front portion is called as the cockpit, where the pilot will be seated. And this is going to be the section for the command and control. And fuselage is going to be the entire part, that is the central part in which the passengers are seated. uh, so the that is the feature of the fuselage is to hold the things together and they carry the payload. And the wings have slats for increasing the lift. And there is going to be a component called the spoiler, which you can see in the automobiles also, that is used for changing the lift, drag, and the roll to a certain extent. And there is going to be a component to change the pitch condition, which is called as the elevator. And for increasing the lift and the drag, we are using the flaps here. And winglets are attached at the end of the wings to decrease the drag. And the turbine engine is attached here, that is below the wings, to generate the thrust. So these are the different components and the functions of those components. The advantages over the traditional materials: we are using a number of traditional materials with respect to the applications, but for the aircraft composite materials, they have some superior qualities. Efficiency, performance, and durability are the superior qualities. For the reduced weight leads to the lower operational cost and emission. And the performance is very high for the aircraft composite materials because of the high stiffness and the strength, which gives the safety and stability. Durability is also very high. The challenges in aircraft composite use: these are the few challenges. That is, cost is going to be one of the challenging or the limiting factor in the aircraft applications. Manufacturing complexity, inspection and repair, recycling are the few limitations or the challenges in the aircraft applications. The future trends in the aircraft applications being, we have to go for the automation in the manufacturing of the components in the aircraft applications. And especially if you are going for the polymer matrix composite, you have to go for the improved resin system, in which we need the thermoplastic composites for the better recyclability and repairability. The buzzword nowadays being the bio, that is a biocomposite is going to be another classification which can give sustainable alternatives. That is, we can use the natural fibers as the reinforcement and the natural resins as the uh, matrix material. And for the smart composite material, for the real-time health monitoring, we can use a number of sensors to the system, in which the aircraft application can be changed into a smart or the intelligent system.